Welcome everybody to lessons in building a metadata-driven data access layer um, at one of the largest banks in the world. We'll dive in soon. I just wanted to just give you folks a little bit of context and a few housekeeping items. Please feel free to use the chat to kind of pop in questions, and we'll kind of try to take that during the course of our conversation today, or we'll maybe have some time towards the end as well, and we can take some questions then too. But feel free to keep kind of popping in on chat and keeping the conversation there. Traditional rules of online engagement, please do be kind to each other and to other participants here as well. And so that'll help us keep kind of an open and fluid conversation going. We will have a recording of this as well that we'll send across to you folks and to those who registered. So so that should show up in your inboxes in a few days. With that, let us get right into it. We'll kick it off with a few intros. I am Tanmai. I'm the CEO co-founder at Hasura. Started Hasura many years ago after getting a sense of the underlying technology to be built at a previous company that I used to run. And as I think we'll talk about in our conversation today, we set out to solve a problem from a very personal pain point, building as developers, building applications and doing things when we were kind of trying to connect data and build applications. And over time, over the last few years, we realized that this problem is way more massive than we thought it was. And a few years ago, I met Ken and was extremely excited by the work that Ken was doing and how Ken was doing. So I'm super privileged and thankful to have Ken join us on the call today and talk about his experiences. And before we begin, Ken, would love to hear an introduction from you and your story.
Yeah, absolutely. So I'll just give you a little thumbnail of my career. I started as a Deloitte consultant in this really fascinating area around exotic derivatives valuation, did all kinds of crazy, interesting things back in those days. Went on to become a managing director over a group of bond trading desks on Wall Street. I was a chief information officer at Koch Industries. I was a chief information officer at Enron, which is a whole nother webinar, but we don't have time for it today. I was also the chief information officer at a global life reinsurer, and most recently, I was a senior architect at Bank of America over a number of different functions while I was at Bank of America. And now I'm working with you, Tanmai, and really excited
That's awesome.
about it.
And so we've Ken's joined us as our field CTO and has been working closely with our teams here and with our customers as well, exercising kind of some of those learnings and refining them. And so it's been kind of amazing to see this come together. With that setup, I'd love to perhaps maybe I can share a slide that I think sets the context up a little bit in terms of kind of describing really, kind of what was happening and what were kind of challenges when it kind of came to data access that needed to happen from several domains where teams were accessing it. What was the situation like, Ken, and what were kind of some of the challenges that were starting to show up?
Sure. So I'm going to talk about a specific situation that I encountered at one of my previous employers. And so this previous employer was a large global bank. And I was tasked with looking at why this very significant internal shared service was not able to produce quality data. What was happening is that executives were getting incorrect information. Some incorrect information was going out to regulators, and this was of significant concern to the overall leadership at the bank. And this large internal shared service was one of the largest functions at the bank and shared its information with virtually all other lines of business. So it was critical that this information was correct.
Got it. And what it, I mean, theoretically doesn't sound like a hard problem, right? It's like, you have the data, you ship the data to people, right? The data ought to be correct. Like what was happening that this data was becoming incorrect, or what were kind of the issues that were happening?
Well, first of all, you have to, let's talk about the scale just for a second, right? So there were probably at least 12 different teams that owned very significant kind of data warehouses, what I'll call them data producers in this larger shared service. They all operated independently and provided information independently to those lines of business, right? And so there was a lack of coordination between them, and information between them really wasn't useful unless you combined it, right? So if I needed, information from team one and team two, I needed that in order to produce something meaningful for a reg report or an exec, right? And so this just became, I'll give you an example of what would happen, right? And I know I have to talk in sort of generic terms because of NDAs and so forth, but I'll try to be as specific as I can. So a team would generally have some affinity with one of those 12 organizations. They would go to one of those organizations and they would say, I need this information. That organization, this data producer, would usually have two responses. They would say, I can get you that except for this other bit. And I will go get that other bit from you by talking to one of my sister organizations. They'll produce that and then provide it back to the requester. The other thing that would happen is occasionally they'd say, well, that's not really part of our, standard procedures. You, as the requester, need to go to these individual teams, get this data, and then assemble it on your own to produce the insight or report that's being requested of you. And that's fine if that happens once. But I analyzed this, and what happens is first of all, these speeds last on average about 7 years in this organization. I would suspect that's true in every other organization as well. The second is every one of those conversations is happening with those data producers like a couple of times a month, right? So 12 data producers, a couple of these conversations every month across those 12 data producers. Over a 7-year period, the end result was just this absolutely incredible ball of kind of data flows. And then when someone comes to it and says, tell me why data is poor quality, particularly, oftentimes it's this data governance team that's tasked with doing that. It's just impossible. It's not possible to figure out what the heck is going on. Right.
Very, very interesting. So it's like you have kind of these situations where data is kind of that the hardness in being able to reason what is happening is, data is being kind of duplicated from one place to another, or somebody's kind of directly accessing data, and then you don't know if they're doing it the right way or even looking at the right thing. All of that starts to basically add up and then become debt a few years down the line when you want to reason about it.
Exactly. And you would think that things like being clear about data ownership, for example, would help solve that. But what happens is every one of these little sort of pollution of data between these different data producers is sort of thought of as an edge case, despite all those rules, and it just eventually overwhelms the entire system. And people can now, when a data requester comes and asks for data, it's like, sure, that's like a 6-month process. Here's a few forms you need to fill out, blah, 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 right? Because all of this internal activity overwhelms the organizations and they can no longer really provide the services that are required.
Right. And so like you said, it's like it ends up being kind of this tension between, if we do it right and we try to make sure that everything is done well, there's kind of this natural slowdown, which means that then you can't give people access to data as and when they want it, because that's what's causing this chaos. So you're always kind of caught between these two extremes of, we can kind of move quickly and do it, but if we do, then it creates a mess. And if we try to upfront fix that mess, then we just create so much process and work that stuff doesn't get done. When you think about, when you kind of think about the players over here, we're talking like hundreds of stakeholders, I'm guessing, right? You have a data governance team, you have data producers. What is it about the way that people are working today that doesn't allow for this problem to be fixed? And it kind of feels like there isn't like a cycle of making it better, that there's an operating model kind of thing that's missing. So talk a little bit about like how many stakeholders here, and what's kind of the root cause of this not getting fixed automatically.
Right. So I honestly, I engage with probably about 100 stakeholders, set up multiple committees to analyze subsets of this problem, gathered a lot of quantitative data around this to come to these conclusions. I don't have the time to go through all of the reasoning behind it, but I can give you the summaries, right? Ultimately, what we concluded was that even if people produced high quality data, the operating model to request or to use data really drove this negative dynamic that ended up producing the outcomes I was telling you, right? That there would be a lot of duplication of data between these teams, or as data would escape these organizations and move into the organization that was requesting it, they would not assemble the data or use the data or interpret the data correctly. So what was fascinating is that the general answer is always to look at the data producers and say they're not producing high quality data. I don't think that was really the problem. The problem was how data was being used, right? And the negative dynamic that it created, where it ultimately overwhelmed the producer with requests to produce very narrow kind of use cases or solutions for these requesters, right?
Got it. Got it. So would it be accurate to say, like, for example, what would happen is you kind of talked about like a particular team wanting a particular way of fetching that data, and then of course they would fetch that same data multiple times. But this kind of composition that was required, that composition was hard because maybe you had to duplicate data or maybe you had to fetch it from multiple places. But the number of these compositions were so many that it would overwhelm these kind of data producer teams, and they just have this infinite backlog of trying to get through everybody's request of trying to do things.
I looked at just one team had over 500 individual views that for these
Wow.
they had to maintain. And each of those views not only included their data, but was pulling data from, again, from sister teams, right? Again, imagine how that would work across many, many teams over many, many years. How do you maintain that? I mean, you
Yep.
can't. It's not possible.
Yep. And then these kind of applications or people who are accessing this over APIs, there's no way to kind of reason about who's using what and are they using it correctly and stuff like that, right? It just becomes impossible. I really kind of like this idea and this focus on data use and data access, and so I put together I've put together from your words this articulation of what I call Ken's rule of thinking about data use strategy, right? So this is what you've often said to me. What does this mean? Give us a sense of what this is.
Sure. Well, I mean, I'll sort of repeat it real quickly. Um, and it's not just data use, it's more of a data governance role in a sense, but we are focusing a lot on data use in this particular use case that we're looking at. But generally speaking, good governance is really says I have to be able to say what I'm going to do. I must be able to do what I said I would do, and I have to be able to prove it. In fact, there's a good friend of mine at Bank of America who just spent years trying to establish these sorts of principles within the regulatory reporting regime. And in fact, a lot of my ideas I might have stolen from him, just a tiny bit. But he had fascinating thoughts as well about this whole idea of how can I prove, right, that this particular result was accurate and came from the right places.
This is, I mean, this sounds, I love things that sound obvious, and this sounds obvious, right? Like this is an idea that sounds like this is the most sensible way to solve the problem, right? Like let's describe what we're going to
But
do.
no one
Let's
measures
first,
this way, right? If
exactly.
you
Yep.
measured yourself this way, you'd start to see gaps in your strategy.
Yep. And I think like that, this kind of comes back to this tension of like, this seems like a very principled approach, which is to say, first, it's very important to write down what we're going to do just as a best practice, right? Like document what we're going to do, and that makes sense. And then do what you've documented, which is great. And then ensure that at any point of time, they are both in sync, right? Which is that we're able to prove that
Right.
our intent and our execution is the same. Which sounds like fundamental underpinning of something very scalable. But I think when it meets the ability to kind of actually execute or do something, right, it it probably has an impact on velocity, right? There's kind of this trade-off between, what we're kind of talking about is the ability to de-risk this kind of or simplify or wrangle this complexity, right? Which is this one axis of what we're talking about. And this other axis is like the speed at which we're able to actually provision access, provide access, do stuff, let multiple teams collaborate, right?
Right.
How, like, talk a little bit about that tension.
Yeah, I was going to say, tell me that. While the earlier seems sort of obvious and kind of dumb, it's also what you probably, I can't believe everyone doesn't agree that's exactly what you have to do. The issue really is it's really hard to do. Like you've got like it's easy to say it, it's hard to do it, right? Which is what you're getting at in this slide, right? So I have to do things rapidly, right? There are immediate concerns that come up that must be addressed. And if I have to do all those, if I have to be able to if I have to be so detail oriented to do those three things in every single thing that I do, how am I going to operate rapidly? And so now you got to
Exactly.
look at these different strategies to improve velocity and the degree of change that you can actually influence through that at that rate of change, right?
Yep. No, makes sense, right? And I think like, and it feels like one of the learnings over the last decade has definitely been that, we need to have multiple teams be productive. It's really important to kind of federate to them, right? To make sure that multiple teams are kind of able to be productive. But kind of that has this tension with how do we centralize governance and access and compliance and standardization, and that kind of stuff, right? So when you kind of think about like your wish list of in how you would like this to actually be implemented, right? What does standardization mean to you? What does federation mean to you? What does that ideally look like in a system that would work well, where both of these would be able to come together?
Sure. So um, all of these terms could be useful, and none of them are sufficient to start with, right? So let's talk about federation. If you need to move rapidly, the ability to subdivide tasks and move them into independent teams is certainly a strategy, right? But if that's all you did, right? Maybe the teams don't have the skills to deliver. Maybe they deliver, but there's no mechanism to integrate the results of their work, right? You have to do other things other than just delegate, right? Which gets to things like standardization. So perhaps standards would allow you to integrate the work of these federated teams, right? But if you standardize without federation, you know, maybe you'll get something, it'll probably slow things down. So you kind of got to do both a little bit. The other issue with standardization is it depends a lot on the standards. Bad standards aren't going to do anybody any good, right?
Yep.
If they're
Yep.
too specific, they almost all are too specific, usually relates to too complex, which usually means there's a lot of effort trying to comply with those standards, and things don't work too well. I think from a standards perspective, my philosophy is always the least you can get away with, see how it operates, and in the same way we iterate on code and other sorts of solutions, you need to iterate on your standards and improve them over time. Do not start with the, too specific standard at the beginning. Err on the side of too general at the beginning.
Got
Um,
it.
Gen AI, great way to accelerate, and I've spent a lot of time with Gen AI over the last couple of years, and there's a lot that you can do with it, but it is not going to code business logic for you. It just won't. It's a great way to help people learn. It's a great way to understand libraries that they might use to accelerate their delivery. It's a good, it has all kinds of potential uses that might accelerate, but if that was your only strategy, again, completely insufficient, right? You need to be able to federate your work with proper, and you have to think through those boundaries and how you do that. If you're going to ask people to code, those people have to have the right skill sets in order to deliver that. Whatever they produce must be some level of standards so that we can integrate the whole at some point, right? And then
Yep.
other things like Gen AI, security, there's other aspects that could also be used to help you accelerate.
Makes sense. And I think like I really like what you said about standardization as well, right? Which is like I think you want to kind of iterate on the standards, right? But then the thing with something like standardization is that it's like standards are a centralized artifact, right? Um, and then having a process or an artifact that represents the standardization to different teams so that you can actually iterate on it is very important, right? You can't it's hard to iterate on standards if it's something that's kind of just in the air and you have 20 teams trying to adopt and iterate on the standards. Like what version of the standard are you even on, right? Like there's a lot of, it's just hard to execute.
Right. There has to be a governing organization that establishes these standards and is determining what these federated entities are, determining division of responsibility and how they're tasked. All of that stuff has to happen. It's not just standards. So that federation and standards all comes together in some sort of central organization that has to sort all those things out, right?
Makes sense. And I feel like, like current approaches and solutions that we've had, and this was the kind of exploration that you were doing when we were chatting, was this, you're kind of like the good governance kind of things that you want to do end up our current ways of our technologies, our operating models of in the way that we execute kind of end up compromising on velocity. And if we kind of increase our velocity, we end up compromising on our ability to kind of enforce or prove that we have standards and that we're executing on them. What we really want to be is kind of in this golden place here where we do have the bare minimum or appropriate required amount of centralization and standards and enforcement, but we're also moving as theoretically fast as possible. Like I remember Facebook used to have this quote back in the day when they were called Facebook, move fast and break things. And I think for enterprise, it's, move fast without breaking things. Do not break the thing, please, right?
I would have said that I think there's been improvements that allow you to hit that golden spot, right? Where you can move quickly, not break things, and prove that you did everything properly. But I think it requires a lot of thought to come up with the solution to doing that.
Yep.
It's not, if it's just divided up between a bunch of teams, task them with producing code that meets certain standards and that defines certain contracts, etc. I don't think that's going to solve it for you. Not at scale. Those things happen more in smaller applications. Application teams operate in that way, but you cannot operate in that way at scale.
Yep. Yep. And I think, and it's been, especially kind of when we're talking about kind of the artifacts of standardization, of authorization, of compliance, right? I think metadata is kind of this concept that props up. And I think it's been very interesting to see kind of the rise of metadata-driven solutions in adjacent spaces, right? And with things like Terraform and Kubernetes, or even workflow engines, where metadata has proved as a very kind of scalable way of governing and executing something that is quite complicated, right? Like, especially if you look at Kubernetes, the infrastructure, it's so complicated, but being able to wrangle that as pieces of metadata suddenly provides it, like this man-machine contract becomes feasible, right? Like, you're doing what you're saying what you're doing, and you're able to prove it, right? In a system like Kubernetes, because it's this kind of metadata-driven implementation of infrastructure.
I'm so inspired by those things. I think that those have been eye-opening to so many people, including myself. And this sort of concept, I think, could be used more extensively to do the things that you're describing, right?
But that said, right, like, I think when people are kind of working, and especially developers and engineers who are working, who are building these access layers and API systems that will finally allow for that last mile of access to happen, or for that data access to be provisioned for a team, metadata does seem to have a little bit of a bad reputation, right? So what is happening? Like, what's the problem with metadata, especially when it comes to, like, on the ground, I want to execute, I want to build an API, I want to build a thing, and I want to make something possible.
Yeah, I have a love-hate relationship perhaps with metadata approaches in particularly in the data space, but they're very, very detailed, and in many ways they turn out, even though in some ways they advertise themselves as active metadata, right? But the general approach is you should do a conceptual model, a logical model, a physical model, right? You should have all of the various entities within it and include the relationships usually as key values in some way, shape, or form. But my experience has turned out that they often don't get materialized as the physical models. And then further, I don't think people generally access the physical models. Once you get into the using data space, you have to overlay it with some sort of simplified semantic model that actually makes it usable, right, for a broad group of consumers. And we also often don't talk about building semantic models, right, at the front end of all of that. And I just find it's generally hasn't been a positive experience to work with data professionals to build data models to support these sorts of organizations. And they often end up being paper exercises, aka passive metadata, that aren't kept up to date and no longer represent, right, describing what you're going to do. If those documents aren't accurate, then they're useless, right?
Yep. I think it's the same parallel when it kind of comes to API metadata and API schemas as well, right? Which is that when we look at the success of systems like grpc and GraphQL, and now to a degree it's getting better with OpenAPI, but these systems where I'm writing the code that describes my API or that implements my API, but that also represents the API schema, eases that implementation a lot, right? But without these systems, if I was just building API endpoints and I had to maintain documentation or the description of my API in a separate document in a Excel sheet or whatever, and then share those artifacts, people hate that, right? Like, there is always this drift and this difference between what I'm saying and what I want my API to do and what my API is doing. One is always ahead of the other, and it's like it's just confusing to everybody and everybody hates it. Nobody wants to do it.
Yeah, definitely true with grpc and GraphQL. Like the metadata drives the execution. OpenAPI kind of depends on your tooling.
Exactly.
They can produce a paper version of it that could be different from how they execute, or not. Depends on the tooling that they use.
Yep.
But yeah, again, I think those are really great examples of things that where they say what they're going to do, right, and then they execute, and then it produces output that can demonstrate that you actually executed in that way, right?
Yep. And I think that this is the point where kind of our worlds collided, right? Which was this was the context that you were in and looking at kind of the landscape and the challenges and the ideas that were floating around. And um and and on the Hasura front, what we'd been working on was this idea of saying, what if metadata, which is an abstract but precise description of models and endpoints or commands and relationships and authorization rules, this artifact, which is actually what the entire business and organization really cares about, this semantic artifact, different teams then care about how it's consumed and the protocol over it's consumed, and different teams care about how this semantic model maps to physical models, right? And that's different concerns. But this metadata artifact, if this description could somehow just magically become the source code of our API service layer, wouldn't that be amazing, right? Like that was kind of the context where
It would be
that
actually.
it so this was kind of like the system that we that we were building that intersected perfectly with I think, Ken, the way that you wanted to see the world in how it was built. This idea that metadata is kind of maintained by these producer teams, and they're able to use that, and then that also drives the implementation. Anything that you want to kind of add here when it comes to thinking about this way of doing things, which is let's have metadata just drive the implementation as well?
Sure. So first of all, I did land on Hasura as the solution, which is how we, but before that, I looked at lots and lots of vendors that I thought might help us improve the way we used data in this particular use case. So I looked at things like query engines. I was kind of inspired by GraphQL in the sense that I liked the sort of the semantics of GraphQL. I wasn't as impressed with the tooling sometimes with GraphQL. And looked at a lot of virtual database solutions as well. But ultimately, I came to this conclusion that I wanted something that was as metadata driven as possible. And that metadata needed to be, in my view, platform agnostic. I need to be able to describe information in a way that didn't tie me to any physical database unless I chose to tie it to that physical database, right? So when I went through all of this, and I did multiple proofs of concept, ultimately Hasura actually fulfilled all of these requirements, and it was really amazing, to be honest, what we were able to accomplish in that particular proof of concept.
No, that and I think that kind of really, especially with like in the way that the world is trending, and we'll show a few demos in just a bit of kind of some of these different ideas really in practice, right? Whether it's kind of understanding of the domain or what becomes possible when you have multiple protocols with the same metadata, right? When it's GraphQL and gRPC at the same time, or being able to connect it to existing metadata catalogs, and really kind of bridging this world, these two different worlds that is just starting to happen. And so we'll show a few demos in a bit. But just as we kind of tee up to that, I think talking about kind of what is important to make this entire approach successful, because again, on paper, it kind of sounds like, yeah, sure, can metadata really describe, the implementation? But I think to your point on ensuring that data producers, they genuinely feel like this way of using this metadata as the source code is going to help reduce my burden and my backlog, that there are key bits in how we make this implementation possible that actually make this idea feasible, right? And so we'll maybe talk about a few of these, but can you talk a lot about kind of this composition aggregation, and
Yeah.
selection as services? What do you mean by that?
Yeah. So my first point is metadata doesn't solve almost anything without the correct services and the division of responsibility between the producers and the consumers, right? So the first thing that I was looking for is some mechanism to compose and aggregate data in a middle tier so that the consumers weren't asking the producers to generate hyper-specific requests for them, right? So it would become more self-service. They could say, I need data set A from this producer. I need data set B from this producer. I know that they can be joined in this particular way to produce this particular composition, and I need these specific fields from it. If I could offload that to the producers, I could reduce a lot of this negative reinforcing loop issue that I was noticing, right? Now producers are very focused on producing high quality data and nothing else, right? It is their only job. It is not their job to respond to every single request, right, from a request store, because there's a self-service layer that provides composition, aggregation, and selection.
Got it. Got it. No, makes a lot of sense, right? And I think that's kind of also what led into that kind of exploration of GraphQL and why a lot of people who are in this space of trying to resolve kind of these internal data access, especially data access that is programmatic and data access between applications, right? I mean,
Right.
why people kind of like lean
Yeah,
into
GraphQL
GraphQL
kind
and
of
start
makes
thinking about
sense.
GraphQL. Right?
Yeah, it
Because it
makes
kind of makes some
sense.
of this self-service. It gives you an opportunity to try to make some of this self-serve, right?
Kind of. I would say the problem with GraphQL is almost none of those things are predefined. It just gives you sort of the infrastructure to do it. And if you federated all of it out to groups and then they all implemented it individually and differently, like you've still got a mess, right? So
Correct.
you still must have some sort of standards, right, around how you implement composition, aggregation, and selection across a larger group.
Yeah, but to your point, and I think that's the most important point, right? Which is that composition, aggregation, and like selection, meaning that if I have a user model or entity and I want to be able to select a precise set of that or a precise set of the relationships from user, that does form a bulk of those backlog requests to data producers, right? So you mentioned like you had 500 of like that 500 items on kind of the backlog or 500 views of the same thing. I'm guessing most of them were just custom compositions or aggregations or subset selections of the same set of entities.
Yeah, well, and imagine every time they need to make a change, right? They got to go back to the original producer.
Update 500. Oh my goodness.
Yeah, it's all crazy. And the other thing that's interesting, at least in the way we define this today, is that these relationships are owned by the producers and they can alter them and improve them over time, right? Without necessarily interrupting or creating problems with the work of the consumer, right? So that, again, it's this division of responsibility around who owns data elements, their definition, and their relationships, who owns the services so that you can combine them for very specific, narrow use cases, right? All of these things, when they're all put together, create this result where data producers now can get some sanity, right? They're no longer being driven with this endless list of requests coming from consumers.
Yep. Just one of the questions or observations from the participants, right? So I'm just going to read that out for the benefit of the group here. So the data consumer will use the middle tier to create the relationship, and that will enable composition aggregation in a self-service fashion. and the data producer will not be responsible for defining the relationships between data objects.
And so that's not what we're saying. The producer defines the relationships, and in many ways they become the constraints. And now consumers aren't able to produce relationships willy-nilly, right? They have to follow the approved, governed relationships that the producers allow them to use for composition, right?
Yeah. So I guess the correction here would be to say that in terms of the question that just came in, is that the relationships and the metadata are still kind of defined by the producers, but informed by the consumer. And we'll show you a demo in a second, but the idea is that as a consumer, you're kind of like consuming this data, right? And let's say you want something from this data, you want a relationship, or you want to know what it's related to. This is now an opportunity to have a productive conversation with the data producers, and the data producers will then create and establish a good relationship and set up a relationship and say, this is what needs to relate to what. And as soon as that is done, exactly to your point, now the data consumers have self-serve composition and aggregation and selection. And this is now from a vicious cycle of infinite backlog items being added to the producer. It's now become a virtuous cycle of like, I'll use this based on my feedback. I will ask you, the data producer, to improve it, and then so on and so forth. And the grunt work of composition, aggregation, and selection is nobody's business. It just ought to work automatically. And we are just talking about important ideas like relationships and entities and stuff like that.
Yeah, and you got the word here. It's just all about reuse. So another way to express it is that data producers were generally in this sort of world where they were producing things for an audience of one. And if the focus is on producing reusable data products, then I think you've turned the corner.
That sounds awesome. I think one of the other things also that is important, especially as we think about this, right? And I remember you mentioning this a while ago, Ken, is that sometimes these ideas are really easy to think about in the context of a small team, and you can get this going, right? Like you have you have some kind of a DSL or some automated code gen that just works for one team and one consumer, and that works. But as you kind of scale this to an organization, it has to scale across multiple teams, right? What are kind of some of those important things that you want to see, or that you would advise people to have when they think about scaling this to multiple teams from an SDLC point of view?
Well, if individual data producers are producing, let's call them data products, data products, the semantic models for those data products and the relationships between data products within their group and across groups. The big question is, it all has to come together and be validated like regularly, and individual teams have to be able to do releases without impacting other teams, right? So you've got to have some sort of mechanism to constantly be aggregating back up all of the metadata from each of these individual groups, validating it and deploying it if it all validates, right? So this whole, you've got to have an SDLC cycle that it really understands this metadata, can validate it and deploy it.
And then provision kind of that access layer, right? That makes sense. And that kind of then brings us to kind of this this piece of actually making that feedback loop happen, right? Which I think you call broad and deep telemetry. What do you mean by that?
Sure. So myself, and I think that most of the industry has been very, very impressed with OpenTelemetry as a standard, as a way for you to understand the operation of distributed systems. So a single transaction comes in at the beginning, right? Or comes in through an entry point, and it winds its way through, all of these distributed systems. OpenTelemetry is very good at explaining how each of those systems reacted and being able to pull all that together into a single story. So if we have metadata that is describing our data, describing our operations, we're defining kind of a common language that we can all use to discuss it, right? If that same metadata is then integrated into your telemetry data, now the proof of what we did is expressed in the exact same language. And then second, the deep part is if this telemetry data can go from, you want it to have as deep a span as possible, right? From the initial request all the way down to the database that provisioned some bit of data to support that request. If you can accomplish that, that means every single request has 100% of the information required to determine if it was executed correctly.
Makes a lot of sense, right? And so this kind of connects. I think this is interesting because again, as we start to move away from this conversation of database and API and point implementations and like observability to make sure that all of that works, which is I think like at a lower level, as soon as we kind of move up a level and say we're talking about metadata and metadata drives implementation, you need kind of that open telemetry conversation also to remain deep, but also level up and say, my telemetry about how stuff is being accessed is augmented and connected with metadata as well, right? So that you know who is accessing what, right? So it's like everything needs to kind of like go up a level, which I think is.
If you've ever been involved in any of these situations, it's just almost comical, right? And a support person who's trying to figure out why something isn't working often is dealing with multiple systems, multiple logging systems, sometimes multiple explanations and terminology that are crossing these systems, including the business terminology that's probably coming in the front door. And they can spend, an enormous amount of time just trying to figure out what the heck happened, right?
Yeah. What is going on, right?
Right. These strategies solve that for you. But it's not just a support person, right? Different people have different reasons about understanding how things operated. Data governance people care deeply about this, right? And I think this sort of strategy produces the evidence for many, right, overseers of your operation.
Yep. And especially I think like the creation of metadata as a standardized artifact for the organization and the usage of something like open telemetry as a standardized way to talk about telemetry creates kind of a underlying foundation that the organization can build upon, right? So now, for example, if the data governance team wants to prove that from an audit or compliance point of view that the data is being accessed in the right way, right, you can now actually build those systems to ensure that. Now you actually have a foundation to execute a data governance strategy where before this you had no foundation even because everything was just everywhere, right?
So what you're getting at is that a metadata-driven design makes execution, assuming you have the general tools to execute all the things we're describing. If you now want to customize or produce additional capabilities, right? These metadata-driven artifacts, both the inputs and the outputs, make the creation of additional solutions like so much simpler, so much easier to kind of think about and actually generate high quality user experiences, right?
And build upon. No, makes sense. And so maybe with that we'll jump into a few demos. And what I'll tee up a little bit on kind of how this metadata kind of really comes together so that people kind of get a sense of what this looks like, right? So for example, I've kind of set up a system here, a sample project, which has a pretty interesting setup where I have multiple different data domains that actually happen to come from multiple different underlying types of databases or systems, right? For example, we have something that comes from a TypeScript business logic system, a ClickHouse system, a Postgres system, in terms of kind of where these different entities are coming in from. And we have this kind of, this is kind of the view of what is actually happening in my overall semantic graph, right? I have products, A product is connected to different types of users, different manufacturers, products have reviews. You have kind of users. Users are connected to different things. And this is kind of like an understanding of your domain, right? So as a data consumer, I'm kind of coming in, and once that metadata is kind of created, and this metadata, for example, with Hasura is in kind of a standardized JSON format and YAML from a CLI and a developer experience point of view. But that metadata is kind of then rendered into this automatically, into this kind of onboarding experience and usage experience for users and data consumers to understand what is going on, right? So I can start to kind of look at different ways of understanding what is connected to what, and where I can start to understand and keep my documentation, also semantic documentation of what is users, right? Like what does it contain? In not a mock example, but in a real example where you have maybe thousands of entities, you're probably going to have 3 or 4 things at least called users. And they're just different users. And having the kind of documentation that tells you which user is what and what it means becomes important. This ability to kind of look at different relationships, different fields inside this particular model, understand kind of what those different fields are, what their types are, starts becoming useful for the kind of ultimate, like the developer, the human or the application that is consuming this data over the API. So this is kind of the documentation or passive part of the metadata. But at the same time, this becomes active because this metadata definition that describes the model and the relationship also becomes the implementation and the access layer. And so, for example, if I look at making a GraphQL API call, I can actually make an API call to fetch this. When we were talking about kind of selection as a service, right? If I want to select a smaller number of entities here, let's say I do ID name. I'm selecting a smaller set of entities that I'm then able to query, and then of course allows me to kind of traverse that graph. And GraphQL becomes a really nice API as well to do this, technically possible with any API protocol. I can then fetch, for example, reviews created by this user, right, and see what the text is, and I can start to fetch kind of this related data. The metadata definition that describes the model and the entity and the relationships also is automatically converted by Hasura into the API implementation as well, and into a standardized API implementation. So that means you have pagination and you have filtering. I want to fetch users where, their name starts with one particular letter, right? Or I want to fetch only the first 5 reviews for every user. So all of these kind of complex pagination and filtering and composition type things are just implemented in a standard way by this layer. And so this layer becomes the place where we can start to enforce those standards that Ken was talking about previously, right? Kind of connecting this back to...
There's a question.
Just taking a few questions. How is some of the standardization enforced, for example, naming conventions? Exactly, right? So when the metadata authoring experience, and if you head to Hasura Docs, for example, you can take a look at what we call kind of supergraph modeling, which has all of the different types of modeling that happens that describes an entity, right? So you're talking about, for example, a model type. So this is what a model type looks like, right? And of course, you can use kind of this CLI to bootstrap creation of all of this. And there's a VS Code extension that makes all of this super easy. So it's error-free and you're just auto-completing your way through it. So the experience is really nice to create this metadata. But this kind of becomes the place where that actual definition happens. And this becomes a place where you can start to put in those conventions, right? So you can decide to have a certain kind of naming scheme and enforce that naming scheme. You can add your own CI/CD linting and primitives on top of this to ensure that any name that you create that is the name of how it shows up in the API follows a particular convention. So all of this becomes really easy to do because this is a type. You have a TypeScript SDK. You have a JSON schema. What you can do is you can look at this metadata and as a part of your CI/CD actually enforce a convention and not even allow this metadata to be published if it doesn't follow your naming convention, right? Because if you look at this, is a really good example where in the API I want to see camel case, but the actual field that I'm mapping to it in the physical model might actually end up being, say, for example, snake case, right? And that's what this metadata is allowing us to do. And this metadata now becomes the artifact on top of which we can enforce these kinds of things.
So, hey,
When there
Tommy,
are, sorry, go ahead, Ken.
I just wanted to mention, so you're kind of showing more the developer experience and how the metadata helps the developer. But and I know we don't have much time here, but I've done a lot of research on how you can repurpose this metadata for other personas, right? So for example, I can build, and I have built off of Apache Atlas, just a few lines of code. You can literally take in all of this metadata that you're explaining right here and produce a very high quality business data catalog, right? That then
Yep,
business users can start adding labels and tags and other stuff too, so they can keep track of this information, right?
yep.
So this is one of the great benefits of being metadata driven is that repurposing metadata for different personas and different user experiences is actually really straightforward.
Yep, and starts to become possible. And that's the nice thing about this is the source code. And because this source code is declarative and has a type, you can actually do meta source code stuff, right? Like you can integrate that with other systems, you can label it, you can create standards on it, because this is, if this was JavaScript, you'd have to write a compiler to enforce standards in the way people write a JavaScript, in the way that they write the JavaScript code, right? Um, Another question on, do we perform joins across data sets and how performant is that? So yes, it does perform joins across data sets. You can actually look at, we were kind of just talking about telemetry a little while ago, right? And in where this data is coming from, what different databases is it going to? In this case, it happens to be kind of going to the same database. And so you kind of see one database request. So Hasura kind of does this query planning where if it determines that the query engine does this query planning where it determines that the actual access, ultimately the data that you're requesting happens to come from the same database, Hasura actually compiles that into a single query. It doesn't even hit the database multiple times. But at the same time, and let me see if I can actually rustle up a good example here. You should be able to fetch data from multiple databases as well. So let's kind of just take a look at what that looks like. So let's say we have products and product details that happens to be coming in from Postgres and Mongo. So let's go to products here. Let's try this out. And let's say that we fetch product, and let's also fetch maybe, I want to see if we have product details. There we go, product details, right? So features. And so this is kind of a query that I'm making that is spanning multiple systems. I'm hoping those databases are up for this sample project. But these are queries that you can kind of make across multiple systems. And in this case, I'm fetching gigantic amounts of data. But as soon as I can kind of make these queries, you can see that you can see the underlying trace as well on how that query is being planned that is hitting multiple systems. You can see what part is slow, what part you want to make faster. Maybe you want to add indexes in certain situations and whatnot. Generally, it's going to be as performant. Our aim is to make sure that it's as performant as theoretically possible from a query planning point of view. So that means that transactional requests, that means any place where you're doing kind of real-time requests, that's going to work with real-time guarantees, right? So you can achieve pretty sophisticated P99s under 300, 400 milliseconds pretty easily, even on complicated fetches. And that's pretty easy to optimize that setup for. If you're looking at true analytical workloads where you want to do joins in memory, that is something that we push down to the database. But in the query engine, we're adding capabilities to make that possible as well. So that you can kind of run this in an analytical mode where you might be fetching massive amounts of data from two different systems and aggregating that and composing that on the fly at the Hasura layer. But right now, our aim is optimized for kind of more real-time access. So anything that you can do real-time should work with the right kind of SLAs that you want to see. Just a quick look on a little bit of observability before we move to looking at some of kind of the higher catalog integrations here. What I wanted to show you folks was the ability to just hide the databases here. But this was, so we kind of looked at the deep part of the telemetry that Ken was talking about, where I can actually see down to the actual database request, even the actual SQL plan or the Mongo aggregation pipeline, the actual query that was executed on the database. I can see everything from the beginning down to that depth. But then I can also start to see meta-analysis, where I can see at a field level who's using what fields. So I can see that when it comes to the user object, name is what is kind of, name and ID is what is most commonly used, and people don't really request for updated ad, right? Like that's not the thing that people are making kind of requests for. I can also see how people are making requests and how people are using those fields. Are they using it as a part of the selection that we were talking about? Are people using it because it's a part of a relationship? I'm not fetching that directly, but I'm fetching that when I fetch reviews, I want to fetch the author and the author's name. Or am I fetching that because I'm doing filtering on that? I'm not really using that to get data, but I'm using that to filter. And that kind of gives you detailed analysis on how your data is being used, which then helps you make decisions on how you want to evolve the models or how you want to even evolve your infrastructure, right? You might realize that this query pattern is better suited by a particular kind of database or a particular kind of workload, and then you can kind of make those investments appropriately. So this is kind of the broad and deep telemetry that is metadata enhanced that you get to see. I'm going to hand it off to Ken quickly, maybe take us over a few demos of what integrating this with other systems might look like, and what ideas can be built upon with this as a base. But this bit is the most exciting bit, so I'm going to have, let's look at this and then maybe we can share recordings with folks.
I don't know if exciting is the right word, but because some of this I just have to kind of represent what the level of effort was that was involved. But I for example, took the supergraph metadata for a sample supergraph, and I built some very simple scripts that just consume that and turn that into a data catalog using Apache Atlas. Apache Atlas is something that Hortonworks really led the charge on, and it's got a fair amount of usage as a data catalog. So for example, here I took all of those meta things like supergraph, subgraph, etc., represented those as types of things that you put into a data catalog. So for example, there is one supergraph. If we look for that, this is the supergraph. It's named Enterprise. I can click through this. I can see that it's got two domains, app and my app subgraph. I can click into the domain. I can see all of the different queries or sort of query endpoints that you could use, and I can see every schema that those queries can actually use, for example. I can click through into here, and I can determine that that particular query is returns an array of a record called app employees, and app employees has these fields, and I can click further and see that that field is tied to a physical database column called address, right? So all of that stuff you were showing, Tommy, is super cool if you're a developer, but it's not going to compute if you're like a data governance guy. A data governance guy is looking for this, right? But it's the same data, exact same data. It's just a different user experience. Now this gives him extra capabilities, right? He can perform audits against this. He can classify data. He can add labels to this data so that he can add more organizing principles that developers maybe aren't as interested in, right? So this is just a really simple example of how you can take metadata and repurpose it to a different persona for different reasons. Tommy or anyone, any of this interesting? Do you have questions? I can tell you a little bit more about it.
And I think like the system is like now automatically synchronized as well, right? Between like that the implementation is now synchronized to this kind of experience of how you're dealing with metadata.
Well,
and I think
updates there again, you're pointing out that updates are really straightforward, right? These are not complex processes to repurpose or transform metadata from one approach to another, for example.
Yep. I think in kind of some of these other examples of looking at how I think that another example of looking at like different protocols, for example, or anything else that you can do with this metadata approach might be interesting to look at too.
Yeah. Well, so a different example, but this is more of a developer experience, right? So if we're able to define some sort of higher level operation beyond composition, selection, aggregation, right? Like a parameterized query as sort of a data product that I'm going to create this sort of reusable data product that I share with my data consumers. Could I do it in a way where I don't care what the preferred client protocol is? You want to do grpc? Sure. You want to do OpenAPI? No problem. You want to do JSON or RPC, right? Put it onto a queue, whatever. So what I did was, again, this is a research thing, but I put this together, and you can see here that I use as my underlying representation. I just happen to use GraphQL because it's a convenient way to define a parameterized query. But I create a single definition of a parameterized query. I reference it back to the other metadata elements in this model. And then I'm able to build code that automatically generates things like OpenAPI. So now this thing is now available as OpenAPI, but it's also available as, and by the way, as a functional OpenAPI. So it actually operates just like you would expect it to. And then I was also able to, for example, turn it into JSON RPC, which a lot of, that's sort of an interesting little space, JSON RPC. And then the other one that's perhaps more relevant is OpenAPI. So in OpenAPI, actually introspection worked. I'm able to find all of the possible endpoints, define, the filters that I'm looking for, and actually generate the final result with this as well. So again, the level of effort to do this is very, very small compared to maybe if you hadn't laid it down that foundation of metadata. So these are just examples. I mean, every single example seems a little bit trivial, but the point is you can do so many of these things, right? The art
No,
of
and
the
I think definitely like the
becomes,
idea of like the multiple protocol stuff is so valuable, right? Because one of the big things that people struggle with, especially when you're kind of doing this giant, like the bigger the problem you want to solve, and we're talking about a very big problem here, getting locked into a protocol is very dangerous, right? So being locked into only GraphQL or only REST is dangerous for the organization, right? And
and the world
having an
changes,
ability,
right?
exactly,
Right?
exactly.
So when they want to do the next thing, the Tanmai RPC, right, that you invented and popularized, right? You're in a position to do that quickly.
Exactly. Exactly. And you can adopt that standard pretty quickly, right? So I think that's that's pretty awesome as well. With that, I know we're super over time. Thanks for hanging on, folks. We're going to send across the recordings for some of this. This was a great conversation. Thanks, Ken, for jumping on. And please feel free to reach out to any of us directly. We'll send out our coordinates on emails to those folks who registered. I'm at firstname@hasura.io. And so is Ken, and we can connect you folks. And so feel free to reach out if you have anything interesting that you want to chat about in terms of data access, how you're thinking about kind of a data use strategy, and the ability or the pitfalls of metadata. But with that, I shall call this to a close. Thanks again, folks.
Yeah.